going to talk a little bit about geometric series. And I'm going to start with this. I'm going to multiply these two things together. 1 minus r and 1 plus r squared plus r cubed plus plus r to the m minus 1. And I can do this by using the distributive law, in other words, foiling it out. So multiplying 1 by all of these is going to give me 1 times 1 plus r squared plus some parentheses plus r cubed plus plus r to the m minus 1 plus negative r, and I'm really not liking this here, so I'm going to erase this. I'm going to make this into a definite 1. 1 times this, and negative r times the same thing. Just using the distributive law here. R cubed plus plus r to the m minus 1. Okay, well now I can distribute 1 through here, and I'm going to get 1 plus r squared plus r cubed plus plus r to the m minus 1. Now I can distribute this negative r through here to get minus r squared minus r cubed minus r to the 4th plus, or actually minus, minus, that's going to give me minus r to the m. Okay, well if I do just a little bit of algebra here, I can look and say, oh, that r is going to cancel with that minus r. That r squared is going to cancel with that minus r squared. R cubed is going to cancel with minus r cubed. There's an r to the 4th here that's going to cancel with this r to the 4th. There's an m minus 1 here that's going to cancel with that m minus 1. And when all is said and done, what I'm left with is 1 minus r to the m. So this is equal to 1 minus r to the m, just by doing some distributive law stuff. And that's the foundation for geometric series. Isn't that wonderful? So what this means is that, in particular, I can divide both sides. In fact, let's rewrite this. 1 minus r, 1 plus r squared plus plus r to the m minus 1 equals 1 minus r to the m. That means I can just divide both sides by 1 minus r as long as r is not equal to 1, and it won't be. And I get that 1 plus r squared plus plus r to the m minus 1 equals this ratio. And then you think to yourself, well, maybe I didn't want this. Maybe I wanted a generic geometric series, which looks like this. AR squared plus plus AR to the m minus 1. Oh, but I can easily correct that by just changing what I did up here. I can multiply A by all of this, and that has the effect of multiplying by A over here. And so this gives me the finite sum for the geometric series. A finite geometric summation, actually. Well, and then use the algebraic limit theorem for sequences, and you figure out that. And then what we can do is we can rewrite what we have over here as a over 1 minus r minus a over 1 minus r times r to the m. And using the algebraic limit theorem, but these are essentially the partial sums, right? So what we're really doing is, by looking at this thing right here, we're looking at the partial sums. But so by using the algebraic limit theorem for sequences, we can see that that this, you just kind of take all the limits individually. The limit for this one is just going to be a minus 1 over r, because nothing's changing. Limit for this one, right, r is going to be less than 1, so that's going to go to 0, and that's going to be minus a over 1 minus r times 0, leaving just a minus 1 over r and